This is the lesson video for the first day of probability and odds. While we talk through the objectives, please get out your notes packet and find where the first section on probability and odds comes up. The objectives over the next 3 lessons that we'll do in the next few days are to be able to talk about the 2 different types of probabilities. One's called theoretical and one's called experimental. We'll work on that in this video. To be able to distinguish between those 2 types of probability and be able to calculate those 2 types. Then in future lessons, we'll work on calculating odds for and odds against something happening, what the difference is between odds and probability, and then eventually to use probability and some proportions with algebra to make some predictions. So make sure you find in your notes where you've got this first day on probability and odds and big idea number 1. Big idea today is that there are actually 2 kinds of probability, 2 kinds of ways of telling the likelihood of something happening. So in the last few days, we've gathered some data about red, yellow, and blue items being selected or drawn at random. So before the experiment was run, we talked about what we might be expecting when there's 6 items, and we can let the gumballs in this gumball machine picture be our what we can see that are our choices for selection. And if we randomly select one, we put a penny in the gumball machine and it picks which one we get. We would like to know what we're expecting, because the first kind of probability is what we expect or what we see could happen. So that has to be able to depend upon the idea of how many of each item are there that could be equally likely to come through that gumball machine. And I see 3 blue in the gumball machine, 2 red, and 1 yellow. So therefore there are 6 items that could each come out of the gumball machine if I put a penny in. So the probability of yellow would be that there's 1 successful yellow out of the 6 total items that we could draw from there. And if you take 1/6 and you turn it into a percentage, it's only about 16 or 17% of the time we'd expect to get that yellow to come out. The probability that we'd expect for blue is that there are 3 blues out of the 6 items. So we would expect that half the time we would get a blue. And red, there's 2 out of 6, so we would expect 1/3 of the time, or about 33% of the time, we would get a red if one were randomly selected for us. So then you ran some data, and we gathered that up as a class, and we looked at what actually happened when we selected these. So I'm going to put some data down. That's what happened from a set of 12 that I ran. This is what I have as what happened when I ran an experiment. So, I could have put a little slash through there, couldn't I? This was only supposed to have 4. Let's see, 5, 4. No, this one's supposed to have 5. Okay. So this is what happened when I actually ran an experiment, and 12 total trials of my experiment. And trials, I want you to add, again, all this to your notes. Trials means the number of times I ran a simulation. I actually conducted the experiment and let something randomly be drawn. So out of those 12 trials, 2 of the times mine came up yellow, 5 of the times it came up red, and 5 of the times it came up blue. So for my results, if I calculate the probability, the times I'd expect yellow then, I got yellow 2 times out of my 12 trials. I got yellow 1/6 of the time. That's actually what I was expecting. So my expected probability matched what happened when I ran an experiment. My blue, or probability of blue, came up 5 out of 12 times. That does not match what we expected. We expected it to come up about half the time, which would have been 6 out of 12. And red, we did not expect to come up quite as often. I got 5 reds out of my 12. So my experimental doesn't always match my theoretical. So my experiment-based probability, and carefully add this into your notes, it doesn't always match what's expected. I should probably spell probability correctly, huh? Probability Doesn't always, in fact, it doesn't usually always equal my expected probability, or what's called my theoretical probability. Okay, so take a second, kind of think about that. When they talk about results in science class, what you expect to have happen from an experiment versus what actually does happen when you run the experiment are two different things. And math says, well, there's two different ways to calculate probability then. There is what the rules of probability say should happen, and that's theoretical. Theoretical probability is based on what we expect to happen from number of outcomes, from our possible outcomes. So we expected, from what we saw in the gumball machine, that we could have number of successful outcomes, like yellow, to number of equally likely outcomes, the blue, the green, and the blue, the yellow, and the red all put together. So we calculated theoretical probabilities back up at the beginning. So would you go back up to expecting? These were all theoretical. We ran that based off the formula for theoretical that said, what are you expecting to have happen out of how many things can happen? So what we calculated up there was theoretical. We used that formula that said how many things can happen out of how many things are possible, how many outcomes are equally likely. So we had theoretical probability there, that the probability of an event is always going to, in theory, be how many outcomes are what we want out of how many outcomes were possible, equally likely outcomes. And you've done a lot with that kind of probability in school before. Experimental probability then is what came out when we actually ran an experiment and saw what happened. So based on what actually happens when we run an experiment. Okay, and the word trial, I'm going to ask you to put down here. Trial is the number of times we run the experiment. Number of runs of the experiment. Okay, if we actually run an experiment, then we take that data, and you have your data from me up above. I ran an experiment. I got 2 yellow, 5 red, 5 blue. And based on that experiment, then I calculated all my probabilities as well. How many came up what I wanted? Out of how many trials, how many times did I run the experiment? So of the 12 times I ran the experiment, I could tell what my probability actually came out in an experiment. These two rarely match. However, as more and more trials are run, so if I kept running that experiment over and over and over millions of times, if more trials, runs of the experiment, are conducted, the experimental probability generally gets closer to what we'd expect. You have probably flipped coins before, and the expectation is that they'd come up half the time heads and half the time tails. But if you did an experiment of 10 coin flips, you might not get 5 heads and 5 tails. However, if you did that experiment a million times, you would get closer and closer and closer to having half your experimental trials come up heads and half of it come up tails. You'd get even closer if you went to 1 billion trials, 10 billion trials. So as you do more and more, these two should start to get really close to each other. So you're going to pause the video here, stop the video, and then you're going to use the next short videos as working through some examples of this.